Let's say you have a prototype game written in C++ and you want your friend to run it. A very common perception is, yeah, but it's cumbersome to build and run a C++ project, right? What if you can just reply with, don't worry, it's literally like running a Python script. And your friend downloaded the file and it just plays when he runs it. And he can do anything he wants by just editing the script. Infinite health, infinite ammo, change the resolution, anything you can think of. And compared to normal Python script, it'll be extremely stable as well, because everything's built from source. So no need to worry about Windows update, runtime changes, binary changes, stuff like that. Everything's guaranteed to run. And if there is any problem, you can just recompile it. After all, you have all the source code you need. That was the scenario I was hoping to achieve a year ago when I started this project. A project that allows you to do quick cross-platform prototyping with not just a single source file like a script, but also a proper project with multiple source files as well. It started out to be a build automation, but slowly turned into a glorified build system. The project is called rant CPP2, and unlike other build systems, it doesn't use an unintuitive, obscure, and poorly documented language that you cannot debug. It uses YAML, which is a declarative syntax for describing how to build a binary. And in the future, you can also use C++ itself, which I call it scriptable pipeline, for building more complex projects. So you can start with a simple declarative syntax, then move to C++ if you need it. After all, this is the language you use, right? It's entirely up to you how to build it. Nothing is abstracted or hidden away from you. Instead, common defaults for different toolchains which you can build upon are provided for you, and you can just get going in no time. There's no middleman as well, because this isn't a meta build system. Anything you set is directly passed to the compiler and linker. Like, why do we have to go through another layer of build system which increases build time, complexity, and debugging time when you can just invoke the compiler and linker directly? Instead, that shouldn't have any complexity. It should have no function calls, no arguments, no state, no hidden behavior. What you see in the documentation should be what you get. And last but not least, the build system should have a modern documentation with examples. Well, this kind of turned into a rant about build systems, but anyway. So let's switch the conversation back to scripting in C++ and let me do some demoing. In here, I've cloned the run cpp2 repository. First, let's go to the examples directory and start off with a hello world example. So we need to include IOStream. And in the main function, we just need to print out hello world. And let's save it and run it. It's working as expected, nothing too surprising. So this is a very trivial example. So let's move on to a more sophisticated example with dependencies. In here, I have quite a few examples. Let's first start off with a static web server. As you can see, it is running right now. Let's curl it with the URL shown on the screen. And it returned us a HTML, which is this index.html. Let me print it out. And as you can see, it matches what we got from the response. Let's also try to get the main.cpp we have just written earlier, because a static web server, in a way, is just a file server. As you can see, the C++ code we have just written, the hello world, is returned as a response. Let's stop running it. Next thing we have is SDL window. SDL is a very commonly used library that is used for games and other graphics applications. This is a minimum example on what you can do with it. You can imagine this as your game, maybe a very simple game, which you can literally send to your friend and run it the same way as I do right now. The example we have here is very simple. A very minimum example with a red square. Very nice. We can also do some logging with different log levels. We also have matplot, which is for plotting graphs. This is another common use case for scripting, right? Maybe plotting some data from a data source or something like that. Let's run it. As you can see, there's two graphs, a scatter graph and a line graph. Nice. So let's edit one of the script. Let's edit the SDL window example. This is just a normal C++ file with a block comment in the beginning, listing the dependency details. So if I scroll down, here we can find the rectangle being drawn. So let's change that from red to blue. And let's run again. As you can see, the change is reflected immediately, as expected. Let's try to do something else. Let's add another plot for matplot. And again, this is a normal C++ file with a block comment at the beginning for the dependencies. So let me add another graph. And let's run it again. As you can see, our new not so linear graph is shown. As you have more and more dependencies, the list of dependencies might get longer and longer. So one pretty cool thing you can do is, instead of listing your dependencies details in your script as a command block, you can import the standalone YAML files instead. So if we go back to the matplot example, what we can do is copy this part, create a new file, maybe call it matplot.yaml, then paste it in, and then edit it to an object instead of a list item. And let's save it. And if we go back to the matplot example, what we can do instead is to import it. Let's import the YAML file we just copied and pasted. So what was it again? Matplot.yaml. And nothing should have changed. Yep, is working as before. So what this allows us to do in the future is to have a central repository of standalone dependency YAMLs, maybe like matplot, SDL, etc., that you can just import. And the whole thing would be a lot more simpler and concise. But that is something to be done in the future, at some point. So that's pretty much it for demoing the scripting aspect of Run CPP2 for this video. There's a roadmap for this project on what things I'm planning to add, but that's probably for another video. I will also make a video at some point in the build system perspective, maybe a bit in-depth, and showing how does it work under the hood. But yeah, you can find the link to the project in the description. If you're interested, feel free to have a try of it or even contribute to the project.